All right, so this next part of the lessons deals with linear functions and their slopes. Again, this is something that's really going to be used in calculus, as basically the whole point of a derivative in calculus is to find the slope of a function. So what we would like to do is like to go over how to find the slope from 2 points, uh, how to use the point slope formula, the slope intercept formula, and then what's the general form of the equation of a line. Right, those are all things that are part of bullet one. Other things that we'd like to do is compute the slope from 2 points and maybe give something about the behavior. Use the or give the equation of a line given the slope and a point, right? So that's the point slope formula. Given 2 points, can you find the equation of a line? So you'd have to find the slope, then use the point slope formula. And then finally, construct the equation of horizontal and vertical lines and discuss their slopes as well. All right, so they tell us here that the standard form of a linear equation of two variables is ax plus by plus c equals 0. And you're not going to see equations written that way very often. What we are used to is the slope intercept form, which is y equals mx plus b. M there is the slope, and we calculate the slope if given 2 points by this formula, right? This is our slope formula. Another way of saying this is change in y over change in x. Sometimes you'll see it written like this, right? Delta y over delta x, that represents change. The other way is, of course, what I have boxed here, which is the difference between the y values and the x values. So remember, you just have to be careful in the way that you plug them in. So you can call either point x1, y1, and the other one x2, y2. What's important is that you're doing the difference in the same direction, okay? So y2 minus y1, x2 minus x1, or you could go the other direction, right? But you just have to do it consistently, okay? The point slope formula is y minus y1 equals m the slope times x minus x1. And x1, y1 is a point that is given to you, and y and x you leave alone. They are variables. Okay, so you're plugging in for y1, m, and x1, and you are leaving y and x alone. Now, if we're talking about a line which has an equation y equals a constant, for instance, y equals 2, that has a slope of 0, right? Which means m is 0. And if we have a y equals equation, that's going to be horizontal. And if we have an x equals equation, that's going to be vertical. And for an x equals a constant, we say that the slope is undefined. Okay, so I'll get into that a little bit more here in a second. So let's go ahead and see if we can't find the slopes from a graph given some points on the graph. So we have the equation for slope. It is y2 minus y1 over x2 minus x1. Again, I can call either of these two the first point. Now, I like to choose the point that has negative values as my first point. And I'll do this one both ways just so you see why I choose that, but you don't have to do that. Okay, so I'm going to call this one x1, y1. This one's going to be x2, y2. So my slope would be y2, which is 5, minus a negative 2, which is y1, over x2, which is 1, minus a negative 3, which is x1. Okay, so it's y2 minus y1, x2 minus x1. All right. Now, again, the reason I chose the negatives as my first point is you see we do minus a negative, which makes it plus. So this is 5 plus 2 and 1 plus 3. So that's 7 over 4. All right, well, let's do it the opposite direction and just see what happens. Okay, so let's switch these now. Let's call this one, let's actually do it a different color. Let's call this one x1, y1 now. Okay, so we would start with y2, which is negative 2, minus y1, which is 5. All over negative 3, which is x2, minus 1, which is x1. So that's negative 2 minus 5, that's minus 7. Negative 3 minus 1 is negative 4. Negative over negative cancels, and I get back to 7/4. So nothing changes, right? The slope is still the same. The reason I like to do it the other way is because it avoids having to deal with any negatives, right? They're not always going to be negative over negative. And the less negatives I have to worry about, the less mistakes I usually will make, okay? And that's just in general for a lot of people. I've seen that in those cases. All right, so let's take a look at another one here. Again, let's also jump back here real quick, sorry. Notice the slope is positive, and we would call this an increasing curve, right? If we read from left to right, the curve is getting bigger in terms of y. So positive slope means an increasing line, okay? So here, this is a decreasing linear function, so you should expect the slope to be negative, okay? So m equals, let's just make this one x1, y1. So y2 is negative 1, and then let's see, y1 is 2, so we do minus 2. Then x2 is 6, and x1 is negative 5, so we subtract negative. So I get negative 1 minus 2, that's minus 3. And on the bottom, I have 6 minus a negative, so that's plus. That makes that 11. And so my slope is negative 3/11. And again, we said we expected that to be negative. So that looks good.